You need to hear this if you're a budding programmer. Imagine a world where computers are like silent giants, waiting for someone to give them a voice. That voice is C programming. It's the language that breathes life into the machines, making them do incredible things. When you think about the core of computing, C is often the magic behind the curtain. It's a language that has not only survived but thrived through the decades, proving its worth time and again. Picture yourself as a wizard, casting spells that make computers dance to your tune. That's what C allows you to do. It lets you write programs that are lightning fast and incredibly responsive. This is because C speaks directly to the hardware, making it an essential tool for system-level programming. C is like the hidden force in the software world. From operating systems to embedded systems, and even in the creation of new programming languages, C's influence is everywhere. Many of the tools and applications we use daily have been built using C or have components written in C. Let's travel back in time to the early 1970s. Dennis Ritchie, a brilliant mind at Bell Labs, created C. His vision was to craft a language that was both powerful and flexible, and he succeeded beyond anyone's wildest dreams. Ritchie's work laid the foundation for one of the most important programming languages in history. It was the 1970s, a golden era of innovation in computer science. The birth of C was a game changer, offering a new way to write software that was both efficient and portable. This meant that programs written in C could run on different types of hardware with minimal changes. Bell Labs was a hub of groundbreaking research and development. The environment there was perfect for creativity and innovation, allowing Ritchie and his colleagues to push the boundaries of what was possible with computer programming. C is like a master key to the hardware. It's fast and efficient, making it ideal for system-level programming. When you need to write code that interacts directly with the hardware, C is often the best choice. Its low-level capabilities allow for fine-grained control over system resources, which is crucial for performance-critical applications. C is the unsung hero behind many things. Operating systems, game development, and embedded systems all rely on C. From household appliances to medical devices, the versatility of C makes it a valuable skill for any programmer. If you're new to programming, C is a fantastic place to start. It teaches you the fundamentals of how computers work, giving you a solid foundation to build upon. By learning C, you gain a deeper understanding of how software interacts with hardware, which is essential for becoming a proficient programmer. Learning C is like learning the language of computers. It helps you grasp the underlying principles of computer science, such as memory management, data structures, and algorithms. These concepts are crucial for writing efficient and effective code in any programming language. Once you master C, other languages become easier to learn. The skills and knowledge you gain from learning C can be applied to many other programming languages. This makes C an excellent starting point for anyone looking to pursue a career in software development. By mastering C, you open the door to a world of programming possibilities. Are you afraid to start your journey into the world of C programming? Fear not. Before you set off, you need to gather your tools. These tools are the foundation of your coding fortress, essential for creating a robust and efficient programming environment. Without them, your adventure could be much more challenging and less enjoyable. Think of these tools as your programming weapons. Just like a knight needs a sword and shield, a programmer needs specific tools to build software. These tools will help you write, test, and debug your code efficiently. They are indispensable in your coding arsenal. First, you need a compiler and an IDE. The compiler is like a magical translator that converts your code into a language the computer can understand. The IDE, or Integrated Development Environment, is your command center, providing a user-friendly interface to write and manage your code. Together, they form the backbone of your programming setup. Picture your IDE as a workshop. It's where you'll spend most of your time crafting and organizing your code. A good IDE can significantly enhance your productivity by providing features like syntax highlighting, code completion, and debugging tools. It's your command center for coding. With an IDE, you can easily navigate through your code, manage multiple files, and keep your projects well organized. This is crucial for maintaining clarity and efficiency, especially as your projects grow in complexity. Two popular IDEs are Code, Blocks, and Visual Studio. They're free to use and offer a range of features that cater to both beginners and experienced programmers. Code, Blocks is lightweight and easy to set up, while Visual Studio provides a more comprehensive suite of tools. Now let's talk about the compiler. Think of it as a translator that converts the high-level C code you write into machine code that the computer can execute. Without a compiler, your code would remain just a series of instructions that the computer cannot understand. This process is called compilation, and it's a critical step in the development process. A good compiler ensures that your code runs efficiently and correctly on the target machine. One of the most common C compilers is GCC. It's powerful and free. The GNU Compiler Collection, GCCC, is widely used in the industry and supports various programming languages. It's known for its robustness and reliability, making it an excellent choice for C programming. Installing these tools is a breeze. Most IDEs and compilers come with straightforward installation guides that walk you through the process step by step. Whether you're using Windows, macOS, or Linux, you'll find plenty of resources to help you get set up. You can download them online. Just follow the instructions. Websites like the official pages for Code, Blocks, Visual Studio, and GCC provide detailed instructions and download links. Make sure to download the versions compatible with your operating system. Once installed, you're ready to write C. With your tools in place, you can now dive into the world of C programming. Start with simple programs to get a feel for the language and gradually take on more complex projects. Happy coding! You need to watch this if you struggle with understanding programming syntax. Imagine you're learning a new language. Just like any language, C has its own set of rules called syntax. Picture a blueprint. Every C program follows a specific structure, like a well-designed building. At the heart of this structure is the main function. This is where the magic begins. Think of the main function as the heart of your program, and headers as the essential ingredients. These headers guide your program, telling it what to expect. Semicolons are like the full stops in a sentence. They signal the end of a statement to the computer. Braces are like the walls that group lines of code together. This structure might seem confusing at first, but don't worry, with practice, you'll get the hang of it. Remember, practice makes perfect. You need to hear this if you're a beginner in C programming. Imagine you're a wizard and your spells are the code you write. In C programming, you have different types of magical ingredients. Integers are like whole apples. Floats are like potions with precise measurements. Characters are single runes or letters. Think of variables as your magical pouches. They store your ingredients. But before you can use a pouch, you need to tell C what kind of ingredient it will hold. To declare a variable, you write the type of ingredient first. Then, you give your pouch a name. You can also put an ingredient into the pouch right away. This is called initialization. Knowing your ingredients or data types is crucial. It helps you cast your spells correctly and efficiently. If you're a programmer, then you need to master control structures. Imagine you're the director of a grand play. Control structures are your script, guiding your actors on what to do and when to do it. They are the secret behind the flow of your program's execution. Picture this. If statements are like crossroads, helping you make decisions at every turn, and when there's an alternative path, else statements are there to guide you. Switch statements are like a multi-choice quiz, handling various options with ease. Now let's talk about loops. They are the heartbeat of repetition, making sure tasks are done over and over. For loops are like a countdown, repeating a set number of times. While loops, on the other hand, keep going as long as a condition remains true. With these tools, you hold the power to shape your program's destiny. Make your program smart, responsive, and ready to take on any challenge. You need to watch this if you struggle with understanding functions in C programming. Welcome to Section 6, where we dive into the world of functions, the building blocks of your C programs. Imagine you're in a bustling factory. Each worker has a specific job, and together, they keep the factory running smoothly. Functions in C are like those specialized workers. They perform specific tasks, and when you need something done, you call on the right function. This way, you don't have to repeat yourself. Write the function once, and use it whenever you need it. Functions are your secret weapon for keeping your code neat and tidy. Think of them as puzzle pieces. Tackling a giant puzzle all at once is overwhelming, but breaking it into smaller pieces makes it manageable. Functions let you handle each piece individually, making your code easier to debug and collaborate on. Creating a function is like naming a new worker in your factory. You give it a name that tells you what it does. For example, a function that adds two numbers might be called addNumbers. Inside this function, you write the code that does the job. This makes your program more readable and lets you focus on one task at a time. You can also give functions some data to work with, called parameters, and get results back, known as return values. This is like giving a worker the materials they need and getting the finished product. For instance, an addNumbers function can add any two numbers you give it. The result is the sum, which you can use elsewhere in your program. Calling a function is like asking a worker to do their job. You write the function's name followed by parentheses. If the function needs parameters, you include them inside the parentheses. For example, calling addNumbers 5, 10 asks the function to add 5 and 10. The function does its job and returns the result. The syntax for calling functions is simple and consistent. Whether you're a beginner or a seasoned programmer, calling functions works the same way. This consistency is why functions are fundamental in C programming. They help you structure your code clearly and make it more maintainable. Think of functions as your helpers. Just like you rely on different tools to complete a project, you rely on functions to perform specific tasks in your program. Each function is designed to handle a particular job, freeing you up to focus on the bigger picture. This delegation of tasks not only makes your code more efficient, but also allows you to think more abstractly about the problems you're solving. Functions make your C programs more powerful and efficient. By leveraging functions, you can write cleaner, more modular code that is easier to debug and maintain. This not only saves you time, but also makes your programs more robust and scalable. In the long run, mastering the use of functions will make you a more effective and versatile programmer, capable of tackling a wide range of challenges with confidence. Am I the only one that didn't know how powerful arrays and strings are? Welcome to Chapter 7, where we dive into the world of arrays and strings. Imagine arrays as magical lists. They hold collections of data, all of the same kind, neatly organized. Picture each element in an array as a book on a shelf, each with its own unique spot or index. Now strings are like special arrays. They are sequences of characters like a string of pearls. In C, you have a treasure trove of functions to play with strings. You can measure the length of a string or even copy it to another. And yes, you can compare strings to see if they match. Arrays and strings are your trusty tools for organizing and manipulating data in your C adventures. I don't think people understand how crucial pointers and memory management are in C programming. Imagine you have a treasure map, but instead of leading you to gold, it points to a memory address in your computer. That's what pointers do. They hold the memory address of a variable, like a map to a hidden treasure. Now think of memory management as the art of organizing your treasure chest. You need to allocate space for new items and free up space when they're no longer needed. In C programming, you have the power to control this treasure chest, but with great power comes great responsibility. Dynamic memory allocation is like adding new compartments to your chest while the adventure is ongoing. This ability is powerful, but it requires careful handling to avoid chaos. Mastering pointers and memory management is like becoming a skilled treasure hunter. It ensures you can write efficient and error-free C programs, making your coding journey a successful adventure. Exposing the secrets in mastering C programming. Imagine this. You've just taken your first steps into the vast world of C programming. You've explored the basics, like data types, navigated through control flow, and even dabbled in functions. But this is just the beginning. Keep practicing. Write small programs and see your skills grow. The internet is your friend. Websites like Geeks4Geeks and Tutorials Point are treasure troves of tutorials and practice problems. Remember, every great journey begins with a single step. And today you've taken that step in the world of C programming. Keep going and happy coding. Don't forget to subscribe, like, comment, and share for more programming tutorials.